Hello friends, welcome back. Myself Vikash Shakya. I welcome you all back on my channel, and today we are going to discuss about the supervised learning in artificial intelligence. But before we deep dive into the supervised learning, I would like to remind you that there was a video where we discussed about the uh, target value and the label data, right? So label data we have discussed about. So label data is nothing but a data where you have the features and the target value. Features means, for example, the feature could be the number of bedroom, the number of bathrooms, the number of uh, you know uh, uh, the number of fans and number of ACs installed already in a flat, and then the target value will be the the price of that flat, right? So this is called the label data, where you have clear distinction of the features and the target values. So using this label data, we use it to train the machine learning model. And when we use the label data to train a machine learning model, then it is known as the supervised learning. Okay. So what is supervised learning? It's the machine learning task of learning a function that maps an input to output based on the example input output pairs. So based on the input and output pairs, it tries to find out a specific relationship between the output and the input. Okay. Algorithm learns from the label data set, which means each training example has an associated correct output. Okay. So every label data has a correct output. For example, the different features like number of bedroom, bathroom, they could be the different columns, and the final column will be the actual price of this flat that you have collected from the real data source. Okay, from the real world data. So this is how the supervised learning trains itself. I mean, the model trains itself. Okay, so based on the information that it has for the features and based on the output, it tries to find out the pattern. Okay, so the goal is to predict the output of new unseen data. What is the goal of supervised learning? It is trained on a seen data, and it should be able to make the predictions on the unseen data. That is the purpose of the supervised learning. Now let's come to the next slide. So what is the classification? Classification is a type of supervised learning where the output variable is a category. That's what we have discussed about, like label data. So output variable is a category, like the price of the flat, or maybe the price of a particular fertilizer, right? Or anything that can be the case, right? The model learns to assign new data points to one of the several predefined categories. So where we can use it, the classification supervised learning models are used to create some kind of machine learning models which can do the spam detection, which can do the image recognition, whether it's cat, dog, or bird. It can do the medical diagnosis, like it's a disease or not, and then some kind of like customer churn prediction. For example, if there are few customers which are leaving your product, right, they are stopping to use your product, then in that case it's called churning. So how many uh, customers in future could churn out, that that you can predict based on the previous pattern, based on the real data of the previous pattern, right? So based on that, that can help you to devise better strategies to hook on your clients, so that you don't lose those clients, right? So those kind of strategies, if you want to make, then in that case the classification models, these kind of classification supervised learning models can be useful. So these are the different examples where the classification supervised learning models are used. Now come to the difference between the classification and regression. So regression we will discuss in the next video, but yeah, uh, regression is a different kind of model. Better would be to I just explain you about the regression first, and then I just could have discussed the difference between the classification and regression. But still, let's see. In the classification, we predict a discrete categorical output, like here, yes or no, the price, right, true, false. In case of classification, it's not price; it's basically the true, false. In case of classification, A, B, C, anything like that. And the regression is where you predict some kind of house price, some kind of temperature, some kind of stock prices. Okay, so what is the key difference? The difference between the classification and the regression is the nature of the predicted output variable. So in case of classification, you can see the nature of the predicted output variable is a binary kind of output, right? Yes, no, right? A, B, or C, true or false. Mostly the binary kind of situations where the something could be spam or not, something could be non-spam, something could be a kind of particular animal, or some it may not be that animal. So these kind of output where some kind of binary decisions are taken, there we take the help of the there it's classification model, right? And then we come to the house price, temperature, stock prices. I mean, prediction of the prices or prediction of the temperature in coming few days. So all those things that we do with the help of the regression model of the AI learning model, which is the supervised learning model. So the difference is the predicted output variable nature. How classification works? So first of all, at a high level, we are going to understand it, because at the deep level, it's all about the programming. That thing I'm not going to discuss here. We have a separate playlist where we are discussing about the uh, you know uh, about the machine learning models, where we are going much deeper into the training part of the AI. So training phase, here you provide the input. Input is nothing but a label data set where it has features and the corresponding class labels, or you can say the target values. And then the second thing is algorithm. Algorithm, obviously, it learns the pattern and relationship between the features and the labels. So what happens that you have certain features and a target value. Features are like the number of bedroom, number of bathroom. These are the features. And what is the label or the target value? The price of the flat. Okay. So what happens that we keep the price of the flat while training. We keep the price of the flat and the features separate. Features are kept separate, and price of the flat, that is kept separate. Why we keep it separate? We keep it separate because you can imagine a situation that if you give a student some kind of questions in mathematics and you also provide him the answer keys, then that child may be able to learn the mathematical questions and how to solve them based on the answer keys. He can look into the answer key and he can decide that yes, this will be solved in this manner. Or you might have taught him that yes, if you have this question, then the answer will be this, right? And he has some examples. So based on that examples, looking into the answers, he can just try to find out like how I can fit into the answer. Right. So you can understand that the learning curve for that child is really bad, because he is trying to fit the answer. So he will be working best. He may be getting the highest marks in the examination if all the questions come from the book itself, the book which he is reading, right? But in case he sees some kind of unknown data, unseen data, or some kind of other question, you know, in that case, what will happen? If he sees unseen data, unknown question, then in that case, obviously, since he has learned based on the answer keys, he has already seen the answer keys. So on this unseen data, the student will not be able to perform better. Same thing is true for the machine learning models. Machine learning models, they perform best when they learn without looking into the answer key. The learning process is same. That is same for us, right? Whatever way we learn and whatever is the most effective way for us to learn, that is also the most effective way for a machine to learn, right? So what we do, we keep the output variables, the target variable like the price of the flat, we keep it separate, and we keep the features like number of bedroom, number of bathrooms, and the area where the flat is, right? The location where the flat is, the locality where the flat is. All these things we keep separate. And first thing is that the model should learn a pattern. What is the pattern? It need to try out a pattern using the features. What are the features? Number of bedroom, number of bathroom, right? All these things are the features. So it tries to find out the pattern, and then it matches with the price of the flat. First, it tries to find out the pattern, and based on that pattern, tries to learn the pattern, which is the formula, which is the algorithm. And based on that, it after that it matches it with the answer keys. Right? First, it learns, and then it checks the answer keys. While fixing the problem, if it sees if it is able to see the answer key, then it will not become a perfect model. Not every model is perfect, but yes, it will not be an efficient model. That will be the right word to say, the efficient model. Right? So If it goes with the uh, you know efficiency, then in that case it first need to find out the pattern, and then it need to look into the answer keys, which is the target variable, and then it establishes a relationship between the pattern and the output variable. So that is what happens at a high level when the classification models are created, and the output is a trained classification model. And how this predicts? It predicts like it takes a new unseen data when you are providing the real world data. I mean, it has been trained now. It is the prediction phase. You want to see whether it is able to predict it better or not, predict the correct results or not, or how much accurately it is able to predict the things. So you give it a new unseen data point, only the features, because you need to know the output. So how you will provide the output, because you are working on the real world data. You want to see that in that locality, if I search for a 5 bhk or 4 bhk, then in that case what will be the price there, right? So in that case it will be able to help you out because it has learned the pattern. Then what you will do, you will provide the number of bedroom, bathroom, everything, and the locality, every feature that it needs, on which it has been trained on which it has found a pattern. So when you pass those variables, those features, then in that case, whatever pattern it has learned, based on that pattern, it will try to find out an output variable, which is the price of the flat in that locality, right? So trained model uses learned pattern to predict the most likely class label, which is the output value, and the output is the predicted class label for the new data point. So this is how the classification model of the supervised learning works. Let's go to the next slide. So what are the different classification algorithms? If you want to, learn about these in detail, because these are the part of the machine learning, these are not the part of the AI syllabus, right? Because these are the different algorithms: logistics regression, decision trees, random forest, support vector mechanisms, and k nearest neighbors and naive Bayes. So these are the different machine learning algorithms using which it can find out, the predicted value. It can find out the pattern. It can fit in any of the algorithm, which whatever fits suit for it, whatever is suited for it. Then in that case, after applying these algorithms, you will get the output on the unseen data. Okay, so these are the common classification algorithms that are used to decide the final outcome, the predicted value. Now come to the final slide. How you choose the right algorithm, because all these algorithms, when you choose them, one of these algorithms, as a machine learning expert, if you are writing a program, if you're writing a AI model, then in that case, what you will do, how you will choose. So these are some of the guidelines, like how to choose the right algorithm. So you need to check the data characteristics. What is the size? What is the dimensionality? What is the presence of outliers? Outliers means which should not be the part of this data for the training data. Those are the outliers. Outliers are those data points which should not be the part of the training. Those are known as the outliers. Then comes the problem complexity, whether it's a binary or multi-class problem. It's highly separable versus overlapping classes, and their interpretability. Some models like decision trees are more interpretable than others. Complex SVMs, these state vector machines. Then performance matrices, you need to find out the accuracy, how accurate you want, what is the accuracy expectation, what is the precision expectation. All these are the different words that you are able to see: accuracy, precision, F1 score. All these we are going to learn. Don't worry about these. AUC, ROC, what are these? We are going to learn about them, because we are not going to create any program. We are not going to create any machine learning model in this particular series. But yeah, you should know, as a AI engineer, you should know all these things. What are these? Then the computational resources. What are your requirements? Training time, prediction time, memory requirements. What are these? The parameters as per you, as per your requirement. So all these things, when you are able to decide, then you are able to choose the right algorithm. Let us come to the next one. Evaluation matrix. Accuracy. What is accuracy? You can see correct predictions versus total predictions can be misleading with the imbalanced data sets, which means, like, if you want to see what is the accuracy, then you have to find out the correct predictions. What are the correct predictions? And then the total number of predictions that it has done. You need to divide from the total number of predictions. and then you find out like how what is the percentage of the accuracy. It's 94%, 90% or whatever. But if the data is imbalanced, data should be balanced, which means that data should be including equally all the data points. It should have the equal data points for all the things. For example, if you are talking about the price of the flats, then in that case, 1 BHK, 2 BHK, 3 BHK, 4 BHK, 5 BHK, all the data points should be there, right? All the relevant data points should be there, which should be helping to decide the actual price. For example, if you are collecting some data to find out whether the males are more prone to having the diabetes or females are more prone to having diabetes, and if you have just collected maximum data for the males, then in that case your model will not be able to decide it correctly. Your model may be biased in that case. It may not give correct results for the females because you have not included that much data. So the data should be fair, and if you want your machine to give your AI model to give fair results, then obviously data should be fair. So the most important thing is the fair data. The fair result is directly proportional to the degree to which you have collected the fair data. That's it. Okay, then comes the precision. Precision means true positive upon true plus false positives. How many selected items were relevant? That is the main purpose of precision. Recall. Sensitivity. It's true positive versus true positive divided by true positive plus false negatives. How many relevant items are selected? Okay. So relevancy, precision talks about the relevancy. Recall talks about the relevant items selected. Okay. First is talking about the relevancy, and recall talks about the how many relevant items are really selected, right, in the output. F1 score, it's the harmonic mean of precision and recall. It balances both. It shows that how balanced your output is. So that is why you take the harmonic mean. We are going to discuss about these mathematical terms in the coming videos, because if these came here, then we should be having some detailed discussion around this. Then we have confusion matrix table showing true positive, true negatives, false positives, and false negatives. So that is the confusion matrix. Then comes the AUC ROC curve, plots the true positive rate versus false positive rates was at various threshold settings. Good for imbalanced data sets. So this is really useful to find out for the imbalanced data sets, so that you can further train it by balancing your data set, right? So these are the different evaluation matrices. And then comes the challenges in the classification. What are the different challenges in the classification models? First thing is overfitting. Model learns the training data too well, performs poorly on unseen data. Sometimes it happens that if you have not refined your data properly, then in that case, what will happen that it has learned the pattern on the seen data, whatever data it has seen during the training. It works perfectly well for that data, but it doesn't work well for the other kind of data. Some other kind of data like the unseen data, where it has to actually predict. Underfitting. When is the problem of underfitting? Model is too simple to capture the underlying pattern in the data. I mean, you have not, just decided the correct algorithm to find out the pattern. So in that case, it becomes underfitting model. So you need to choose wisely. I just made it reverse. So you need to choose wisely what should be the correct algorithm for you. What should be the appropriate, not correct, basically the appropriate algorithm for you, which should be chosen to make this classification model. Then comes the class imbalance. One class significantly outnumbers the others, leading to bias models. The same thing. I told you that if you have collected all the data related to males and not that much for the females, then it may be that you have created it may be that you end up creating such a model which doesn't predict the things well for the women, and but still it predicts the things well for the men. So that is a bias model. You need to take care of this, because until you have the biased things in your model, then your model is not following the ethical principles, and that model will not be acceptable. Those models only which are fair, which are following all the RAI guidelines, which are following all the RAI principles, only those models will survive. Otherwise, no other model deserves to survive, basically. Then comes the feature engineering. So it may be the feature engineering has not been done correctly. Feature engineering, it's the process of creating and just preparing the data so that it should be appropriate for the model to be trained. Okay. So maybe the feature engineering, whosoever is doing the feature engineering, the machine learning expert, or the feature engineering expert or the data engineering expert is not equipped with the knowledge of the feature engineering, and he has not created sufficient data or the accurate data so that we can have the better model. So in that case, it could be a challenge. So feature engineering should be taken care of with utmost importance, which means like your data engineers and the machine learning engineers who are really doing the feature engineering, they should be good enough. Okay, then comes the data quality. It may be noisy, it may be missing, or whatever source you have used and you have got the data from that source, it may have these kind of problems, noisy, missing, or inconsistent data. Then comes the model interpretability. Understanding why a model makes certain predictions can be challenging for complex models. Means the explainability is one of the features of the today's model, right? Explainability, which means like it should be able to explain why I have given this answer, why I reached to this answer, why I not given some other answers to you. So that is known as the explainability, or you can say the model interpretability, right? So if the model is really complex or your data engineering has been done poorly, then in that case, such kind of models will not be that much interpretable, or these will not be able to do the predictions properly. So what is the application? So in the healthcare, finances, marketing, spam detection, as we discussed, image and speech recognition, and sentiment analysis. So these are the things which where the classification can be done, right? Because classification are like few classes you create. Like if you are talking about the sentiment analysis, it could be frustrating, it could be angry, it could be positive, it could be negative. So there are certain classes. So for those kind of models as well, the classification model, machine learning model can be useful. Then comes the future trends. Let's talk about some of the future trends in classification. One is deep learning. So we are going to discuss about these in the coming videos. What is convolutional neural network and what is recurrent neural network? All these things. Automated machine learning, explainable AI, right? Developing techniques to make complex model more interpretable. I mean, it should be able to tell that how it reaches to the answer, because explainability is not only for me, the end user. It's also for the model developers. After looking into the details, like how it has performed, why it reaches to that answer, why it reached to that answer, based on that data, it could be uh, really useful for the model developers, those who are developing the model. It could be really useful for them, right? Federated learning, training models are decentralized data sets without sharing raw data. So these things we are going to just do in detail because the video is getting longer. And there is continuous learning, models that can learn new tasks without forgetting previously learned knowledge. So these are the future trends in the classification models. So these will be the kind of models which will be created. I mean, based on these parameters, the models will be improved in the coming future. So that's all. Any questions if you have, you can simply put in the comment section and I will try to answer all of them. Thank you. Have a nice day and bye bye.